Hey everyone, and welcome. Today, we're going to tackle something super useful, a tool that basically turns complicated problems into simple puzzles. We're talking about solving systems of equations, specifically with the substitution method. So yeah, let's just dive right in.
Okay, so think about this. How do you solve a puzzle that has two mysteries? Like, imagine you have two missing pieces, and you can't find one without getting a clue from the other. Well, that's exactly what a system of equations is. It's a puzzle with two unknowns, two variables that are totally linked together. And today, we're going to learn exactly how to crack that code.
So here's our game plan. First, we'll figure out what this puzzle is all about. Then, we'll get our secret weapon, the substitution method. After that, we'll put it to the test with a few examples, see how it applies to real life, and finally, we'll do the all-important final check to make sure we nailed it.
All right, first up, the two-equation puzzle. So what exactly is this thing? Well, we're talking about something called systems of linear equations. I know, it sounds kind of formal, but really it's just a fancy way of saying we've got two equations that are linked. They're a team, and we have to solve them together.
And here's the key thing to remember. Our goal isn't just to find nx or ay. No way. We're on the hunt for that one single coordinate point. You know, that one specific x, y pair that makes both equations true at the exact same time. It's the sweet spot where everything lines up.
So how in the world do we find that magic point? Well, that brings us to our next section, unlocking with substitution. We're going to use a really cool technique called substitution. Seriously, you can think of it like a master key that's designed to unlock pretty much any of these two-equation puzzles.
And the plan is a super simple three-step process. Step 1, you solve one of the equations for just one variable. Get it all by itself. Step 2, you take what you just found and you substitute it. You plug it right into the other equation. That's the main event right there. And then, step 3, you just solve what's left. It's a game plan that works every single time.
All right, enough theory. Let's see this thing in action. It's time to solve our first puzzle. We're going to walk through this one together, and you'll see just how easy this master key really is to use.
Okay, here's our first system. And hey, check it out. This one's kind of nice to us. See equation 1? The y is already all by itself on one side. It's literally telling us, hey, y is the same thing as negative 2x minus 9. How great is that? Step 1 is already done for us.
Okay, now for the big move, the substitution. Since we know from equation 1 what y is, we can take that whole chunk, the negative 2x minus 9, and drop it right into the y spot in equation 2. See that? We literally just swapped out the letter y for the stuff it's equal to.
And boom, just like that, the y is gone. And we have an equation with only one mystery left, x. Now it's just regular algebra. We distribute that negative 5, which gives us 6x plus 10x plus 45 equals negative 19. We combine the x's to get 16x. Then we got to move that 45 over, so we subtract it from both sides. That gives us 16x equals negative 64. One last step, divide by 16, and there we have it. The first piece of our puzzle is found, x equals negative 4.
We're so close. Now we just take that x equals negative 4 we just found, and we plug it back into that nice simple first equation. So y equals negative 2 times negative 4, that's a positive 8. Then 8 minus 9 is negative 1. And that's it. The second piece of the puzzle is found, y equals negative 1.
So, putting it all together, our solution is the point negative 4, negative 1. That's it. That's the one and only spot on the graph where these two lines would actually cross each other.
All right, you ready to level up a little? Let's try one that's a little more involved. This time, we have to do all three steps ourselves. If you look at this system, you'll see that neither x nor y is by itself. So that means it's our job to do step 1.
Okay, let's take a look at that first equation, negative x plus y equals 3. You know what? Getting y by itself here is going to be super easy. All we have to do is add x to both sides of the equation. And just like that, we get y equals x plus 3. Step 1, done. And now we just follow the recipe. For step 2, we take that x plus 3 and substitute it into the y spot in the second equation. We solve for x, and we get x equals negative 1. For step 3, we plug that negative 1 back into our easy equation. Y equals negative 1 plus 3, which means y equals 2. See? Same process.
So our answer is the point -1, 2. And this is a perfect time to show you how to check your work. You can do an algebraic check where you just plug the numbers back in to make sure they work. But what's really cool is the graphical check. It shows you what's actually happening. That solution, -1, 2, is literally the exact point where those two lines cross on a graph. The math and the picture tell the same story.
All right, I know what some of you might be thinking. This is a neat math trick, but am I ever going to use this in real life? And the answer is yes. So let's shift gears and look at where this stuff actually matters.
So check out this scenario. A drama club sells a bunch of adult tickets and student tickets and makes a certain amount of money. We also know that an adult ticket costs twice as much as a student one. So what's the price of each? We have two unknowns, right? The adult price and the student price. And we have two key pieces of info. Sounds an awful lot like a two-equation puzzle, doesn't it?
This is where we translate English into math. Let's call the adult ticket price X and the student price Y. That first sentence about total sales, that becomes our first equation. 64 times the adult price plus 132 times the student price equals $1,040. The second sentence about the adult ticket costing twice as much, that's even easier. X equals 2Y. And there you go. We just turned a word problem into a system we know how to solve. Now that we have our system, we can use our substitution key. The second equation tells us X equals 2Y, which is perfect for substituting. We plug that into the first equation, do the math, and it spits out a clear, real-world answer. Student tickets are $4 and adult tickets are $8. Okay, we've got our prices, but we're not quite done. There's one last, super important part. The final check. Look, in math, and honestly in life, it is always a good idea to verify your solution. This is how we know for sure we got it right.
So let's run the numbers. 64 tickets at $8 each, plus 132 tickets at $4 each. Does that equal $1,040? You bet it does. And is the adult price $8, double the student price, $4? Yes, again. Both of our original conditions are met. Our solution is absolutely perfect.
You know, there's this great quote that says, "The essence of mathematics is not to make simple things complicated, but to make complicated things simple." And that's exactly what we did, right? We took this messy-sounding situation with tickets and prices, and we used a simple, logical tool to make it all make sense and find a clear answer. So now you've got this key, this method. It's a powerful tool for solving all kinds of problems. It can find where two lines cross, it can figure out ticket prices, and honestly, it can be used in so many other situations. So the real question is, now that you know how to use the key, what other puzzles are you going to unlock?